All right, it is practice time. I'm going to go pretty quickly, or I'm going to go as quick as I can. And I'm going to factor as I go. This looks like m minus 6 and then m plus 1 to factor. Now I'm going to go ahead and do what I told you in the video. I'm going to go ahead and turn that into multiply and move this to the denominator. And then I'm going to factor out this business. I see a 48, so my gut's telling me 8 and 6. And does that work with what's in the middle? Yes, it does. Okay, so that was that. And now let's cancel what we can. Cancel, cancel. And that's all I can cancel. So the end of my problem looks like this. Done. All right, number 2. It's another division. So let's go ahead and turn it into multiplication. And then on this side, I definitely know I can still factor. Or usually, I don't want to say every time, but like usually you can factor. Is it 5 and 4? It's going to be a 10 and a 2. And let's see if it's a plus 10 and a minus 2. And that's good. Then I can cancel these two and those two. And the only thing left is x minus 3. All right, on number 3, same thing. It's division again. It's getting very predictable, isn't it? Okay, on the bottom, I can take out a 3v on the bottom, and what's left behind is a 5v plus 8, and then times, I'm going to flip those, so the v minus 1 goes to the bottom, and on the top, I know I can take out a 3 again. Can I take out something bigger? I think I can take out a 6. That would be a 5v plus 8. Okay, cool. So, yay, a lot of stuff's going to cancel. These are gone. These are gone, and all that's left is 6 over v minus 1. Cool. Number 4. It's a division problem. I'm in shock. All right, I need to take out a 4x squared. So if you missed the squared part, you might want to go back and find that. Oops, I took out that 4. Okay, so all that's left here is an x, and then plus, would that be a 5? Yep. And then times, I'm going to flip this side, x plus 5 over 1, cancel, cancel, and that is what's left. All right, now we get to the addition. I'm not going to lie, I do not like the addition and subtraction. Oh my gosh, I think they take me too long sometimes to really think about. So here's the actual problem. Now I factor denominators. Now this can't be factored and this can't be factored. And what that tells me is that the common denominator is both of those, okay? So this one was missing a 2k minus 3, so that means the top needs to be multiplied a 2k minus 3, okay? Now there's a plus in between. Then I have a 5, and did the 5 need anything to be multiplied by? Well, yes it does, because this one had the 2k minus 3, but it was missing the k plus 5. So whatever you multiply on the bottom, you multiply on the top. And then it's just called distributing and combining like terms. So this will be an 8k squared minus 12k plus 5k plus 25 over all of that. It's kind of skipping a step there. Now the numerator is 8k squared. What would that be? Minus 7k plus 25. All over k plus 5 times 2k minus 3. That's the final answer. It's gross and it took a long time, and that, my friends, is why I don't like addition and subtraction. All right, number 6. I've got a 3n over 2 plus n plus 4 over, what is that? 3n minus 6. Okay, so I'm going to go ahead and factor this denominator, which means I'm going to take the 3 out, and when I take the 3 out front, it becomes an n minus 2. 3 times n minus 2. Now, this and this and this, these are my factors for the problem. So my common denominator is going to be a 6 times an n minus 2. That's how I would write my denominator. There's other ways. If you didn't factor it, you could write it how you already wrote it, but I like to factor and then kind of make it a little easier. Now, what is this one missing? Well, this one was missing all of that, right? It's missing the 3n minus 6. So I'm going to multiply this one by 3n minus 6. Plus, now this n plus 4 that's here, what was it missing? Well, this denominator was only missing the 2, so I only have to multiply it by 2. So whatever was missing on bottom, you got to multiply to the top. Now, distribute, 9n squared minus 18n plus 2n plus 8 over 6 times n minus 2. Final answer would be 9n squared minus 16n plus 8 all over 6 times n minus 2. Excellent. So that's how I would do my final answer there. Okay. Now the fun part, we get to start graphing. I hope you girls and guys read the directions, because if not, this was the longest assignment of your life. But if you read the directions, I only had you doing little things on each part. So like on number 7, as I write these, I'm going to go ahead and factor them, just in case somebody cancels. Okay, nobody canceled, but it's still good to factor. So on number 7, it just wants the vertical asymptote. So since nobody canceled, the vertical asymptote, I'm going to put VA, is at x equals -3. So you're setting this to 0 and solving. And that means that the domain is all real numbers such that x is not equal to -3. Now that's how I would write it if you did interval notation. Negative infinity, -3, -3, positive infinity. It's whatever you want to do, really. Okay? Number 8, same thing. It will just want the, vertical asymptote. So the top is x plus 3 times x minus 3. And the denominator, it looks like I can take out a -2. Let's see what happens when I take out a -2. That's x squared plus x minus 6. Okay, now does this factor? It does, I think. Isn't that like a 3 and a 2? -6 would be a +3 and a -2. Okay, so you factor once and get that. When you factor it completely, you get this. And that's important because why? Well, because look, cancel, cancel. So since that canceled, the only thing left on bottom is that. So the vertical asymptote is at 2, which means the domain is all real numbers, except x is not allowed to equal that 2. Okay. Number 9, are we finding something different now? Number 9 and 10, you want the end behavior asymptote. So I'm actually not even going to factor these because it doesn't care about holes and asymptotes, vertical asymptotes. It just wants that end behavior stuff. So I need the highest powered term on the top, which is that, over the highest powered term on the bottom. Now, once you have that and the powers match, our rule says to reduce, and that is your asymptote. So see how quick and easy that is? If you know what to look for and you know what terms to pull out, these are super fast, okay? This one, the highest powered x on top is there is no x, okay? So it's like, there's only a 4, so I guess steal the 4 since there's no x up there. And on the bottom you have an x squared. So the bigger power is in the denominator, and what does that mean? It means it's 0 automatically, and you're done. All right, number 11, identify the holes and the x-intercept. Okay, so 11 and 12, we're looking for holes, I'm going to forget that, and x-intercepts. Okay, so as I write this problem, just like the last couple, I'm going to factor as I go. So gross. That would be a negative. I'm going to go ahead and take out the negative and then try to factor it. If I take out the negative, that would be a -1 in the middle and a -2 in the back. Yep, that would be it. And then on the bottom, I'm just going to take out an x. And looky there, those cancel. So, a hole at 2, comma. Now why did I write 2, comma? Well, once you figure out your x that canceled, you have to take that x, plug it back in, and figure it out. So 2 plus 1 is 3, and it's over a 2. So it's negative 3/2 because there is a negative out front there. Okay, so that's how I'll do that. X-intercepts, I'm supposed to set the y to 0 for x-intercepts. So this is what is left in the problem, right? So I could multiply both sides by x, gone, gone, gone. And then I'm setting this equal to 0, which means negative x is positive 1, which means x is negative 1. Whew! So the intercept is at, I'll do it like that. The intercept is at negative 1, 0. That one was kind of trippy with all the negative stuff going on, so I hope it went okay for you. I did some creative factoring right there, and I did skip a step in my head. If you had trouble with what I did here, take out a negative first, recopy all 3 terms, then factor that, and you'll get the same thing I did, I promise. Okay, number 12. Same deal. Let's factor as we go. So f of x is, this one's going to be, what am I at? Okay, so it's like a 4 and a 1. And let me look at the signage. It needs to be negative, negative. And then on the bottom, same thing. I'm going to take a 2 out and then see what's left. If I take out a 2, it would be a 7 in the middle and a 12 on the back side. So that's 3 and 4. I think that works. Yes, it does. Okay. And once you do that, cancel, cancel. So there's a hole at 4. And we need the y value. So let's take that 4 and plug it in. So there'd be a 3 on top and a 2 on bottom. 3 and a 2. Is that right? Yes. Okay. So that's how we would work that. Now for our intercept, we're setting this side equal to 0. So the denominator's not going to matter once I multiply, okay, by both sides, because this is still a 0. So it looks like the x-int is at a positive 1. There we go. So some of these I go a little faster because I do assume that you've already done them first, and hopefully that's not too fast. 13. Find everything and sketch the graph. Oh my gosh. All right, so I'm going to try to go fast, and let's just pray this works out okay. All right, let me start by factoring. And I'm going to get 12, 3, and 4, x plus 3 and x plus 4. And on the bottom, it's going to be a negative 3. And that'll be an x squared minus 9. Uh-oh, which means that factors again. So x squared minus 9 actually turns into x plus 3 and then x minus 3. So that's cool. Those cancel. So I know I have a hole at negative 3 comma something. So let's plug in a negative 3. That'll be a 1 on the top. And on the bottom, that would be a negative 6, positive 18. 1/18. Yikes, that's tiny. Okay, so now I'm going to take what the leftovers are, and I'm going to find everything else. Okay, so based on the leftovers, I know that the vertical asymptote is at 3. I know that my end behavior asymptote is I need to analyze this one over this one. So x over negative 3x, the powers match, so we just reduce, and the coefficients are the answer. So that's going to be where my end behavior asymptote is. And what's next? Intercepts, okay? Let me set this side equal to 0. When I do that, the denominator is going to end up going away whenever I multiply both sides by it. So my intercept is going to be at negative 4, 0. And what about my y-intercept? The y-intercept is when you plug in a 0 for x. So if I plug in a 0 for x, I'm going to get 4 over 9, 4/9. Cool. This is enough information to graph. I mean, look at all... I've got all of this data, okay? So over here, let's make it happen. A hole at negative 3, 1/18. That's kind of impossible to draw on my crappy grid. Okay. I've got a vertical asymptote at 3. La 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 la. The in behavior asymptote is at -1/3. So we'll just have to make that look like -1/3. And then -4, 0, we cross. And at 0, 4/9 we cross, which is a little over the halfway mark, right? Okay. That's what we know. Let's play connect the dots. These three are kind of in a row. It makes it easy. Woo, woo, woo. Okay, so we're playing the connect the dots. And remember, these graphs look like the swishy stuff, right? So I know something's happening over here. My gut tells me it's happening in the opposite quadrant. And I'm not going to check this because I know this is going to be it. But hopefully you checked it or you picked up a calculator and you can see if we're right or wrong. Okay? So that was exhausting. All right, now let's try 14 and hope that it's not as exhausting. But I'm sure it is. Okay. On the numerator, I'm going to take out an x. See what happens. Down below, I get this. Now, nothing canceled, did it? All right, that makes this fun. Nothing canceled. And so that means there's no hole. But there is vertical asymptotes in 2 places. It's at 3 and -3, since they both didn't cancel. So 2 vertical asymptotes. In fact, that already scares me, so I'm going to graph as I go. 3 and -3. All right, let me go ahead and find my end behavior asymptote, because I'm thinking about asymptotes right now. Now on this you compare the highest powered term on top, which is an x squared, over the highest powered term on bottom, which is an x squared. And that's going to reduce to 1. So at y equals 1, there will be an end behavior asymptote. And now the only thing left to find are my intercepts. So let's take our equation, and it may be easier just to go, since nothing canceled, I'm going to go back to the original because this will just be easier to plug stuff in, I think. In my mind anyways, that might be easier. So if I set all of this to 0, the denominator doesn't matter. So what could go here that would make this, you know, cancel out to 0? Well, if x is 0, it's definitely going to be an issue, but another number is going to make this thing and disappear, and that's going to be a -4, because if I plug in a -4, just math it out, guys. -4 squared plus -16, so that's going to also make this a 0. So I need to have intercepts at both of those. Okay, and then to get my y-intercept, I'm plugging in 0 for x, so it's going to be 0 squared plus 4 times 0 over 0 squared minus 9. Okay, well, when you do all this math, I get 0 over something, and 0 over something is always 0. Okay, so, and we've already got that on our picture. So now that I have points, I need to start making this graph happen. Now, there's going to be a section of graph everywhere. Like this is going to have something happening, this piece has something happening, and then over here, something's going to happen. So I've got to kind of guess. Now, I've got 1 point to go by here, and if I just do that swoosh thing I told you about, it's going to look like that. And I'm guessing that that's right. But in the middle, since there's something here, you got to be really careful, because a lot of times you're not going to cross that in behavior asymptote. So my gut tells me there's going to be a parabola here. Now, to check my gut, I just need to pick an x value and plug it in and see if I'm right or wrong. So let me pick an x value of like 1, okay? If I take 1, that should be lower. If I take 1 and plug it in, I'm going to get 1 plus 4 is 5. 1 minus 9 is negative something. Okay, it does need to be negative, so I know I did that right. If I take -1 and plug it in, I'm going to get the same thing, I think. Maybe not. Let's check it. -1 squared is 1. -1, ooh, I'm getting a -3 over another negative number. That stinks. Okay, this is supposed to be positive here, so guess what? My gut was wrong, and that, my friends, is why you check yourself. That is correct on this side, but it doesn't come back down over here. It's going to go back up, so it's going to look like a cubic or something in the middle. Now, I have no idea what's happening over here. It could be a swoosh up above, or it could be a swoosh down below. And the only way to check that is to grab an x and plug it in. So 1, 2, 3, 4. I'm going to take 5. Let's see what's happening when x is 5. So when x is 5 and I plug it in here, I'm getting 25 plus 20 is a big number, right? Over 25 minus 9. Okay, it's positive, and that's all I care about. I don't even care how small the fraction is. Since it's a positive number, I know that little swoosh is going to be up here. So feel free to check me on a calculator and see how close it is, but I think this is pretty good. And remember, in pre-cal, it's not about exact values. It's about knowing your graph's behavior and approximating where it's going to be. So this is good enough for me. I hope you guys did okay with this. This was a long assignment. I'm sorry about that. But we'll see some of you in tutoring next week. And thanks so much for doing this program with me this summer. I hope you got something out of it, and I hope you have a great school year. Later.